Hi everyone, today we're going to look at growth and decay rates of exponential functions. To start, let's do a quick review. Let's consider an exponential function in the standard form, f of x equals a times b to the x power. Just remember that a is the y-intercept, and if it is positive, if b, the common ratio, is greater than 1, then this function is growing. If b is between 0 and 1, the function is decaying. Some examples where you may see exponential growth are the balance in a savings account. If you invest money over time, you will see exponential growth, or the amount of money in your savings account increase. Another example that's certainly prevalent in the world right now is an example of a virus spreading. Right now it's COVID-19, but this would apply for any germ or bacteria. Some examples of exponential decay. A plant decaying. Once the leaves start to turn brown, the plant dies very, very quickly. The depreciation of a car, and that's just the value of a car. It could also apply to the value sometimes of a home. When you invest in a car, you make that initial purchase. After a few years, the value of the car is not what you paid for. You put miles on the car, you put wear and tear on the car, and so the car is not as new as it once was. Therefore, it's not worth as much as it was when you initially bought it. So let's look at an example. Consider the exponential function f of x equals 500 times 1.05 to the x power. This models the amount of money in Tyler's savings account, where x represents the number of years since Tyler invested the money. So how can we determine if the money in the account is an exponential growth or an exponential decay function? Remember our rule on the first slide, where if b is greater than 1, then it is an exponential growth. And in this case, b is 1.05. This value is greater than 1, so we have an exponential growth function. What is the rate of growth or decay? We need to be able to figure that out. We know that 1.05 is the common ratio. And we know that Tyler has invested 100% of his money in his savings account. That's where this 1.00 came from. We took 100% and we're writing it as a decimal. The 1.05 is the amount of money that Tyler has in his savings account after 1 full year. If we find the difference between his initial value and where he's at after 1 full year, we end up with 0.05 or 5/100ths. To change this decimal back into a percent, you multiply it by 100 and you get 5%. This 5% is the rate in which his savings account is growing. The 500, remember, is our value for A. This is also the initial or starting point. In this case, 500 is the initial amount that Tyler invests in his savings account. So there's a little rhyme for you. Initial amount in Tyler's account. This is also the y-intercept. This says consider f of 8 equals 738.727721895. While this is correct, is it an appropriate answer in this context? And honestly, we have to say no. Because we're talking about money, we should always be at 2 decimal places. So $738.73 would be an appropriate answer in this context, but not repeating decimals. So it's important to be mindful of that. An important study tip, and please take note for this. You will see the rate of growth or decay expressed as either a decimal or a percentage. Either way, so I wanted you to be mindful of that. It just depends on the problem with how it will be written, and either one is correct. Let's look at another example. Example 2. Consider the exponential function f of x equals 21,000 times 91/100th to the x power. This is modeling the value of Robert's car, where x represents the number of years since he purchased the car. We need to look at whether the value of Robert's car is growing or whether it's decaying. So again, we need to check out that B value, the common ratio, to get the growth or decay. In this case, B is 91/100ths or 0.91, and this is falling between 0 and 1. When it falls between 0 and 1, we are looking at an exponential decay. The rate of growth or decay means we need to take the 1 or 100% of what the car was initially worth when Robert purchased it and subtract that common ratio. This will give us 0.09. In order to change this decimal back into a percent, we multiply any decimal times 100 and we'll have the rate of decay as 9%. The 21,000 is the value of A in the equation. That's our initial value. So in this case, it's the amount that Robert paid for the car. Another important study tip to note or write down: when you are finding the decay rate, you have to subtract the B value from 1. If you are finding the growth rate, you subtract 1 from B. Go ahead and try the independent practice question now, and when you are finished, click to the next slide to check your work.